Thank you for joining us for the New Jersey Weather and Climate Extreme Signs of a Changing Climate presentation. I'm Donna McCallie-Holly, Grant and Program Director for the Lake Apacon Foundation. The program this evening is part of the Lake Apacon Foundation Historic Flood of 2000 and Climate Change Program and Exhibit. It has been made possible by a grant from the New Jersey Council for the Humanities, a state partner of the National Endowment for the Humanities. Please join me in welcoming Dave Robinson, a distinguished professor of geography at Rutgers University, and for the past 30 years, he has been our New Jersey state climatologist. He's a frequent speaker on issues pertaining to New Jersey's weather and climate, and is a contributor to the Intergovernmental Panel on Climate and to the U.S. National Climate Assessments. Dave has been a member of the National Academy of Sciences Board of Atmospheric Science and Climate, is past president of the American Association of State Climatologists, has received a Lifetime Achievement Award of the American Association of Geographers, and is a fellow of the American Meteorological Society. So Dave, I'd like to invite you to please share your screen and begin your presentation. Thank you.
Okay, Donna, thanks very much. It's a pleasure to be with you virtually. Let's get this evening to talk about, my livelihood in a sense, the weather and the climate of our great state. And in particular, tonight we'll be looking a little bit more to the highlands. I will provide several opportunities during the course of the presentation for some questions, and of course leave ample time. We'll leave no question unanswered to the end. Got a lot of slides to show. I want to give you a grand overview. It's great that this is being recorded and you can get a hold of the slides. If you want the slide deck, you could always send me an email. My email will be at the end of this presentation, or simply just find a state climate site online and ask for the slides. So anyway, pleasure to be here. We're talking about extremes and climate and weather and extremes in climate. And bringing it home to Lake Apacon, thinking a lot about the 2000 flood up there in August. We're looking at a photo right there. That building should not be considered a houseboat. It's supposed to be a land. That August of 2000 was so enormous on a local basis, but enormous such that it actually didn't just flood a river, it flooded a lake, as many of you well know. So this is the outline. Don't worry, you won't be here all evening, and a few slides on each, but you'll see how we sequence through these so you get a sense of where we are in the presentation. So I'll start off with greetings from the Office of State Climatologist. Yes, we have one. Yes, it is situated at Rutgers University, more specifically in the School of Environmental and Biological Sciences, and even more specifically, the New Jersey Agricultural Experiment Station. I'm an appointed position. It is apolitical. It comes indirectly through a gubernatorial decree in the 1970s that the dean and the executive director of the Ag Experiment Station shall appoint a state climatologist. So there is an official nature to it. As I said, apolitical. I'm a Rutgers professor, and that gives me a lot of flexibility to go in there and build up a program to serve our state. As the state university, Rutgers, I teach, I do research, and this is the service component of what I do at Rutgers. It involves some research as well, and oftentimes some teaching also. But we're here to help people make decisions, but by providing them with information and expertise. We help you make a decision. We're not going to make a decision for you. We're going to provide that information, expertise on weather and climate that will help you in deciding whatever is on your mind, and whoever that may be, it can be from the governor's office to the National Weather Service to state agencies to the public sector, NGOs, private sector, as well as individual citizens. So we serve everyone, all comers. And the idea of state climate offices, of which every state has one except Massachusetts right now, is to serve. And we cooperate with regional and national entities as well. But kind of our credo is this: locals trusting locals. We know our state, we know our communities, we know our infrastructure, and so on and so forth. And that's where we bring the most to decision making on a statewide or down to the local level. I'm a native of Jersey. I grew up in Bergen County, so I've lived virtually my entire life in the state, which gives me, and it's a lot of years now, so it gives me a view of what's going on in the state and how it's evolved and how it's impacted the state. So it helps us help you make decisions. So that's it for the State Climate Office. That's our website. I write a monthly narrative about the previous month's or season's weather. We have a top 10 list at the end of each year. There's all kinds of information you can gather from the site. You click on that map on the top there, and we'll talk to you at the end of the presentation about our weather network, and even an opportunity for you to join as a volunteer precipitation observer, which is under this New Jersey. We'll explain what COCOROS means in a bit. Let's get right to it. I've talked about weather and climate already. And, some people sometimes say it's weather versus climate, and it's really not. There really is a continuum of weather and climate. But if you want to break it down a little bit, weather is this week, short-term phenomenon, a thunderstorm, a squall line, a particular nor'easter coming up the coast, a beautiful sunny day, or a hot, humid day. That's weather, and climate is the longer term pattern there. And by longer, it could just be a couple of weeks, a couple of months, a couple of years, or multiple decades. So it's where we get to that boundary between the weekly and the multiple weekly is where we really have that nexus between weather and climate. And when we're talking extremes, that's really important and interesting. And we're talking about dealing with these, adapting, or trying to mitigate these extremes. We can, in a sense, kill two birds with one stone. We can adapt to be able to handle a weather extreme, but while we're doing that, it can also help us adapt or prepare for a climate extreme in the future. And I think that's what's so critical to keep in mind, that they're not over here and over here, let alone battling each other. They're this continuum of weather into climate. But a better way of looking at this is, if you will, weather is your mood, climate's your personality. If you got cut off at an intersection today, you were in a surly mood, but otherwise you might have a very, and I expect you do, an affable personality. Some people say climate is what you expect and weather is what you get. I take a little exception to that because we are talking extremes, and I'm not saying we necessarily expect climate extremes or weather extremes all the time, but it is part and parcel of living here in the mid-Atlantic states, in the middle latitudes in New Jersey. And extremes we do have. This is just a taste. We'll talk about a few more specific ones in a while, but you see, living in the middle latitudes, we really, and I'll explain in a minute why, we get a wealth of different climate extremes and weather extremes here in New Jersey. These are more of the weather variety. A tornado happens to be a picture of the strongest tornado to strike New Jersey since 1990. And it was down in Gloucester County on September 1st with Ida moving through the state. This is an ice storm that's iced in our weather equipment right up at High Point Monument. I don't know if you may remember this. This is November 15th, 2018, where a quick 4 to 6 inches of snow in the middle of a weekday afternoon resulted in massive gridlock from southwest Jersey, central Jersey, North Jersey. It was just bad timing for a storm that, had it occurred on Sunday morning at 5 in the morning, would have been totally ignored. So sometimes it's not just the magnitude of the extreme, it's the timing of the extreme. Forest fires, we have them up in North Jersey, but of course, the pinelands are known well for how quickly they can turn dry and burn. The lower picture is Maniloking, where the Barnegat Bay joined the Atlantic Ocean back with Sandy in 2012. Wind damage from Sandy blacked out 80% of the state at one time. Hail doesn't always get this big, but this was outside on the campus about a decade ago, but we had tennis ball size hail in Camden County just last month on one afternoon. Another flood, this is not a Hippagon flood or a tropical storm flood, it's a localized flood outside of Philly a couple of years ago. And then drought. We're not going to talk too much about that, but that is Spruce Run Reservoir in March, when it should be filled with water, back in 2002, quite a ways back. So those are kind of the weather extremes. Short term get hit and really have to live with these and hopefully cope with these. This is a little bit longer term, where weather meets climate. The top figure here is the last 12 months of precipitation anomalies across New Jersey. In other words, this is last June, and the red shows that it had below average precipitation, about an inch below average. But then along came July, August, September, October, all with above average precipitation. And we annotate the top 10, the 8th wettest July. Well, the 8th wettest in how long a period of time? 8th wettest since 1895. So well over a century, it was in the top 10. And then along came November and December, which both made the top 10 for dryness, and combined were the driest end of the year on record, the driest combined November, December on record. And then it was followed by about average precip in January, February, but then March was below average, and we were starting to go, uh-oh, are we going to be falling into a drought situation, which worries everyone in the state, because everyone needs fresh water, drinking water, and so on and so forth. But then, fortunately, we went above normal in the precipitation department in April and in May, and we're doing pretty well this month. So no drought concerns right now. So those are, I might add that these graphs are updated monthly on the website, on the state climate website. Then we looked at temperature, and the red is an above average month, blue below average month, and you can see that above average months rain. Now, I mentioned that the extremes go back to 1895. I should have mentioned that the normals, or the departures from normal, are based on a 1991 to 2020 30-year average. So if we were averaging all the way back to the turn of the 19th to 20th century, these red bars would be even higher, and the blue bars might disappear, because as we'll see in a little while, New Jersey has gotten considerably warmer over the last century. And this just shows you these months are warm compared to the last 30 years. Now the anomalies are compared to the last 127 years. And you can see a lot of top 10 warm months and seasons. We've had 3 below average out of the last 12 months, but 9 above average. So you may say, well, okay, we have to deal with extremes on occasion in the weather and with the climate, but what's the big deal? Why am I here listening to this tonight? This is a very interesting figure They haven't updated it for 2022. It's out of the World Economic Forum, not a bunch of climatologists or scientists even. And what they did, they rated natural and human-induced extreme situations, let's just say, and they put them on this graph. And as you look to the right, it becomes more likely. So the likelihood of this occurring increases, and the impact increases as you go up this way. So unlikely, but a high impact would be weapons of mass destruction. But how about something that has a relatively high likelihood and a high impact? And right over here, I know it's very small, I apologize. It's climate action failure. And infectious disease, interestingly enough, is up there as well. But then you come down here, not quite the impact, but still a high likelihood, and it's extreme weather. So it dominates this corner of the figure. And that's why this is so important. This is judged. Weather and climate extremes are judged internationally by non-scientists, economists and such, as having high impact and high good. So pat yourself on the back for sitting here and listening to me drone on this evening. Okay, on to the climate system. Just a couple slides here. First of all, the global climate system. That means everything is connected to everything. You can't look at one part of it without knowing how it influences and is influenced by another part. And you see a lot of spheres here. The sun provides the heat, provides the energy. The atmosphere is involved. The hydrosphere, our oceans, 70% of the land surface covered with ocean. The lithosphere, that's the geology of things, mountain ranges, plains. The forest, fields, deserts, which lack a lot of biologic mass. The crop, that's all things frozen. Glaciers, ice sheets, sea ice, and something that actually outside in Jersey is my research specialty is actually global snow cover. I've been doing it for 40 years and maintain a global snow cover database. So that's my favorite sphere. But let's cut right down. Look what's right dead center in the middle. It's you and I. It's farms and fields and deforestation and roadways and factories, human activities. We are part of the equation, if you will, part of this system. We have butted in, if you will, on what was a purely natural system millennia and longer ago. Bringing it a little closer to home, that's global. Let's now bring it to North America and specifically the middle latitudes where we live. And I've already kind of hinted at that. We're kind of in that's, as I call it, a squeeze play. And that's what gives us 4 seasons. That's what gives us a lot of variety to our weather, even within a season. That's because it's constantly being a battle between the warmer, drier, or humid air to the south and the colder, wetter, or drier air to the north. I mean, we're halfway to the pole, but we're halfway to the equator. We have this huge continent off to our west and this large ocean off to our east. So right where we are, we're all squeezed in. And that's what makes our weather so interesting, so variable, and sometimes so extreme. But the fact is, when we turn to Jersey, we have a lot of different factors within the state that influence our weather. But because we're near an ocean, and we're not at a real high latitude or a real low latitude, we're not at a high altitude either, we tend not to get the worst of the worst. I know that flood in 2000 was about as bad as it can get on a local level. Sandy was bad, but it could have been even worse. We get blizzards, they could be worse. I mean, I don't want to say we don't get anything. We certainly saw that with Ida just last September 1st. We tend not to get the strongest tornadoes, for instance, too. But we get some variety around the state. And maybe your eyes are peeled up here too, your neck of the woods, where you've got a little bit more altitude. You're a little higher latitude than the rest of the state. That leads to generally a colder environment. Interestingly enough, the altitude leads to a wetter environment. The highlands are the wettest part of the state, not the coast, because the air as it comes in and is lifted by the highlands helps to condense the moisture, create clouds, and eventually precipitation. So the wettest part of the state is the highlands. Highlands get about a foot more precipitation a year than down in Atlantic City, which gets about 40 inches. The highlands gets about 52 inches on average. So we have altitude, latitude, these surface conditions I'm talking about here, urban environments, the pinelands, the fields of Southwest Jersey, or the forests of the hillsides, or the valley, open valleys of the Northwest. Surface conditions vary. And of course, if you're near the coast, land-water contrast. It was much warmer today up in the Hapatcon area than it was right along the immediate coast and about 20 miles inland. The sea breeze today, because it was pushed inland by a little bit of a larger system, sea breeze came west of the today. Sometimes it doesn't make it that far west, but it didn't make it over to the Delaware Valley or Northwest Jersey. So it was low to middle 80s, low 80s, basically, inland. And near the coast, it was in the low 70s for part of the afternoon. So there we go, global to zonal to local Jersey weather, and how it all ties together. And it does, it's all linked together. Just like all those systems within the climate system are linked together, all those spheres, I should say. Now, I figured since we're talking about the big flood, I turned to New Jersey precipitation and how we get our precipitation. We'll talk a little bit about the August flood in 2000 flood in here as a feature of this section. First of all, we get our precipitation in North Jersey, in New Jersey, in three different general means. One is mid-latitude low pressure systems, nor'easters, or low pressure that tracks through the Great Lakes and brings moisture in here. We call these mid-latitude lows, and they are generally found from October, November until May, sometimes into early June, but it's a cool season type of system. We tend not to get many of them outside of the cool season. And if it's cold enough and you're high enough in elevation and you're far enough north, you can get a lot of snow out of these. And I thought I'd bring this one to bear here. This is big storm last year, not this year, but last year, that dropped anything in the yellow is greater than 2 feet of snow. And it tapered down such that down along the Atlantic coast was just a couple inches of snow. So a huge gradient in New Jersey due to maritime effects, latitude effects, elevational effects, sometimes the track of the storm. And this was certainly a biggie for the northern half of the state. Now, interestingly enough, that was turned around this past winter. Not much to talk about. The snowiest location in New Jersey this past winter had 36 inches of snow for the entire winter. And it was the township of Galloway down in Atlantic County, because they had a storm on the 3rd of January that no one in the north got, and on the 29th of January, which the east half of but up in the northwest, you didn't get it. Now, up near High Point and some of the higher elevations up your way, got near 30 inches or so. But it was one of those winters where the storm track really dominated where the snow was to be found. So that's one way. Another way is to get it through a tropical system. An Irene, in 2011, a Floyd in 1999, and then Ida on the 1st and 2nd of September. Ida had been a Category 4 hurricane and hit Louisiana, kind of started petering out, crossing the Appalachians. It got here to the mid-Atlantic late in the afternoon on the 1st of September, and it merged with a frontal system. It was able to start tapping moisture from the Atlantic Ocean, and all hell broke loose. And with that, the second deadliest natural disaster in New Jersey history. The deadliest still is Sandy, with about 40 deaths from various causes. This killed 30 New Jerseyans, mostly, almost exclusively by drowning. What happened here was unprecedented, not in the total amount of rain that fell, although it was near the rain fell. And you know that on a smaller scale with the Sparta-Hepatcon flood of 2000. But instead of this being isolated in one small area of the state, it crossed the state in a 6-hour period through a highly inhabited area, densely populated area. And you have to realize everything in this swath where you can see here with the pinks and all, that was 2 months of normal rainfall in 6 hours, not 24 hours, which would have been bad in itself, but more manageable in 6 hours. Anywhere in the north here got a month's worth of rainfall in about 6 hours. But notice South Jersey missed out on the rain. They got the tornado down here in Gloucester County, but it was mostly the Route 1 corridor north. And I might add, of all the 30 deaths from drowning were right where the pink is, from down in Hunterdon and Mercer County up through Somerset, into Union, into Essex, and up into Bergen County. There were no deaths from drowning in the Northwest where, only a month's worth of rain fell. And none further south, and amazingly, none with the tornado, which leveled multiple homes. So this was a tragedy. Now, 30 people drowned. So there was problem with communication. We saw the rain coming across the state. Our weather network, I'll talk about later on, we were seeing 3-inch-an-hour rainfall rates starting in the Southwest there and hanging in the north. That data was being fed every 5 minutes into the Office of Emergency Management, was briefing the governor. Every 5 minutes, it was going to both the local National Weather Service offices in Mount and out on Island, who were issuing flash flood warnings, and eventually the highest flash flood warnings, a flash flood emergency. And the word got out there, and we'll never know how many lives were saved due to this, but lives were lost. And that's because people didn't hear the warnings, or they didn't understand the magnitude of these warnings. But again, this was an extreme, if you will. And there's a photo of the Ef3 tornado. Again, strongest tornado since 1990, one of the 5 Ef3 tornadoes since 1950 in New Jersey. And there's been no 4s or 5s. So this is one of the 5 strongest tornadoes in the last 70 years in New Jersey. The flash flooding. This is Elizabeth, New Jersey, where several people drowned in a basement apartment because they couldn't get out of it. This is the flash flooding. And then with that, the rivers rose. And this is New Jersey the next day when the Millstone River, right near the confluence with the Raritan River, essentially tied for the highest flood on record, tied with Floyd in 99 and Irene in 2011. Those 3 floods, quite likely the 3 largest floods by a large magnitude in the Raritan Basin in central New Jersey, going back to at least colonial times. That's the amazing thing is, 99 was Floyd, 2000 was the flash flood in the Hepatcon. 2004, there was a flash flood down in Burlington County near Tabernacle. This Ida, 2011 Irene. Sandy brought a lot of rain to South Jersey, 8 to 12 inches of rain to the sand soils there, but only a couple inches central and North Jersey. That was a matter of the wind, and along the coast, it was a matter of a huge storm surge. We had Ida, which gave us record river flooding, but also gave us unprecedented expanse of flash flooding. So, and this is Manville, downtown Manville. Side streets look like that. Just a couple of days later, the president, Biden, was there a couple hours before this shot was taken. I literally can look out my window here, and I saw the smoke coming from several homes and a catering establishment that exploded due to gas explosions because they were inundated with, and because I live right across the Millstone River, fortunately high enough not to be in the flood area, but just tragic. But let's turn to the third way we can get precipitation, and that's warm season local storms. And there's none more evident, more potent than what we saw essentially on August 12th, 2000. There was some rain leading into that period and a little afterwards. So you're going to see one figure which shows you rain over a couple-day period, but most of that rain fell during the morning hours of Saturday, August 12th, 2000. And with that, dams washed out, lake flooding. Later on, I'll show you a picture of a roadway ripped out by the flash flooding from this enormous event. Now, how enormous was it? We'll never completely know, but we have a pretty good idea. If it happened today, we'd have a much better idea because we have more stations out there observing. Radar helped a little with estimates, but Patcon Sparta area is a long way away from the National Weather Service radar down at Fort Dix. So it kind of can miss its precip estimates. But we had a variety of ways of drumming up data from this storm, from observers out there, people that went around and talked to people. My dear close friend, Nick Stefano, is kind of the weather guru of Sussex County. We've known each other for, oh my goodness, 35 years through a group called the North Jersey Weather Observers. And Nick tried to gather some data. And what we know is it was a bullseye, but oh my goodness, what a bullseye. 16 inches, maybe. There's some anecdotal records of 18 inches, but I think it's very fair to say that at least 10 inches, probably more in the 12 to 14 inch range, fell for the extreme rainfall in that event. And again, in a very short period of time, but notice over a relatively small area, northern county, only an inch. Down further south, these 3, 4, 5 inch totals, they were not the morning of the 12th. They came later on. And I'll tell you why I know. I was a scoutmaster for a number of years. And it just so happens that Saturday morning, we were breaking camp at Camp Alamucci, which is up right just west of the, it's off, you see it going off Route 80 and all. We had a little rain the night before, and I saw the thunderstorm blossoming. I didn't have a cell phone with radar on it or anything, but I guess I knew enough to tell the boys, get down to the cars. So the only ones that really got soaked were we dads who were finishing up breaking camp. But we got the kids safely into the cars, and we were sideswiped by that. Multiple inches of rain, no doubt, but not what was happening just to our east that we didn't know was happening. We got out of there, Route 80 down to 206 in Netcon. And I live down in Somerset County, and we went down 206. I got home, I mowed the lawn that early afternoon. And then the rain came as the system that was stuck, locked in up in the Sparta Patcon area, finally started moving, got a little more widespread driving forces and pushed the rain elsewhere, but not nearly with the magnitude. What you had there was like a chimney. It's in the atmosphere trying to move it through. Thunderstorm comes through and it rains at 2 an hour for a half hour. So you get into a rain. But right there, the storm parked, maybe in part because of topography, but there was also no driving currents in the atmosphere, and the air started rising. And that means adjacent to it, the air sinking, and that pushed more air into it. So it was like a chimney that just stayed in one place. And that's how you get those localized floods of the Sparta, Hepatcon flood, and then down to the south, that 2004 event in Tabernacle, where a foot of rain fell in relatively short order. And actually, 10 days before Ida, at the onset of was a similar flash flood in southern Middlesex County and a little bit of western Mercer County, right about down here, that flooded out several communities. But again, localized nature. But nothing really beats what was experienced up in the Hepatcon region, because so much rain fell and the topography is such that the runoff was quite rapid and extreme. So I was asked to do a little anecdotal talk about that flood. So I in on the fringes of it, I guess you could say. And then finally, before I ask for a few questions, sometimes the spigot turns off. Sometimes we get dry, and 81 was a big drought year. That led to the building of the Monksville Dam upstream of the Montague Reservoir, the last reservoir to be built. 98 to 2002, right in the midst with Floyd and your flood, was a dry period. In 2002, we had the last emergency in New Jersey. It's been 20 years. Teased on multiple occasions, but it hasn't gotten this bad. And we should all be grateful for that. Now, quickly, Holly, do you see any questions, or should I just move on to the next section?
Sorry, I had to find my unmute there.
That's okay. That's okay.
I don't see any questions yet. We do have a few comments. Rob Bond was saying for the flood of 2000 that he remembers saying, gee, when is this rain ever going to stop? And seeing the Weather Channel radar show the storm was spinning in place for most of the day. Cliff London was saying that there were fish swimming across 181 in Woodport by flash. And Larry Orleans is saying the rainfall was so severe it looked like fog out the window.
Wow. Yeah, I mean, we're talking about rainfall rates. You hear of the 100-year flood, 100-year rainfall. That means that's a 1 in 100, a 1% chance of happening every year. Yeah. These rainfall rates, the recurrence interval, were in the multiple 100 years. Just like with Ida, where we had 1,000-year recurrence rates for 1 hour and 3 hour rainfall. That's what was being experienced in Sparta. Will you ever experience that again right over Sparta and Hepatcon? It's a very small probability, but it's not improbable that it would happen again. But next time it might be somewhere else. So yeah, thank you for those anecdotal remarks.
We do have one question that popped in from Gray Turtle saying, I wonder whether this is a time to ask about storm basin design. Given the rising rain numbers, should towns be paying attention to redesigning storm basins for big developments?
That's a great question. If you'll bear with me and make sure I speak to it when we talk about climate change in just a few minutes, I will address that. And it's very topical question too. So thank you for that.
28.
So let's move on here and look at North Jersey, New Jersey, and climate change. One take-home point: climate's changed throughout Earth's history. There's nothing new about the climate changing. In fact, that area in light blue was all covered with an ice sheet 20,000 years ago. The area in dark blue, there's evidence that sometime in the last couple 100,000 years it was covered with ice. It didn't quite make it down that far. Sea level was much lower because there was so much ice on land that you had to go out to the continental shelf margin to go to the beach back 20,000 years ago. And this is, whoops, This, and I don't know what happened to this image. That is so weird. This is somehow it got blown up much larger. And when it, I'm sorry. Basically, there was an ice sheet in northern New Jersey moving. It was melting backwards or reaching its peak and melting backward 20,000 years ago. And it was carrying a lot of rocks along with it. And when the ice melted, it just dropped rocks. And if anyone's ever been out to Pyramid Mountain and seen tripod rock, these are glacial erratics that were just dropped down right in that incredibly interesting pattern 15 to 20,000 years ago. And they haven't budged since. So there's tripod rock if you've seen it. But let's fast forward. Those changes, we understand why a lot of those changes occurred. A lot has to do with the way the Earth orbits the sun. And in the longer term, it's where the continents sit relative to the oceans and the poles and the equator. When we're talking millions of years, when we're talking tens of thousands of years, we're talking about the Earth orbiting the sun and the axial tilt of the Earth. But these changes took thousands and tens of thousands of years to unfold and change. Now we're talking about change that's happening in our lifetimes and in multiple generations. And it's demonstrably evident. And we know it's happening now and it's affecting New Jersey. And cutting right to the chase is because of human activities. Now, it says here, significant portion and recent changes. By significant, when you're talking about changes that have occurred in the last 4 decades or so, since about 1980, the vast majority of change when it comes to warming and precipitation change in extremes are due to human activity. So we can't put specific numbers on everything because the fact is the natural system is still operating. We're just operating on a more juiced up, or it's like the weather and climate system are on steroids. Or another way of looking at it is that we're working at a higher foundation. Every day is being influenced by climate change. Today was a little, it would have been 50 years ago, a sunny day. Maybe it was a little warmer, a little more humid, a little sunnier, but everything that's happening day to day in our weather and our longer term climate is happening within a changing climate world. And we have multiple lines of evidence for this. We have the greenhouse theory on the top left. That makes there's a natural greenhouse that makes our planet habitable. It's like putting a blanket on the bed. You keep some of the energy from your body, in this case, some of the energy that makes it from the sun down to the Earth's surface, stays near the Earth's surface for a little while longer than it would in the absence of this atmosphere that surrounds our planet, this greenhouse atmosphere. So, if you're a little colder at night, you put another blanket on the bed. Well, what humans are doing is putting on top of this natural blanket, we're putting an anthropogenic blanket, if you will. We're adding to carbon dioxide. And by warming the atmosphere, we're giving it the ability to hold more water vapor. And water vapor is the most ubiquitous greenhouse gas out there. So we're just adding to the natural greenhouse. So this is physics. This is basic physics. It's the reason why the planet is habitable, is that we have a natural greenhouse. So it stands to reason if we're augmenting this greenhouse, it's going to make the planet a little more warm and promote more extremes in looking back in the past. We try to recreate the climate system through mathematical equations, basic laws of physics and conservation of energy, momentum, moisture, run through the world's fastest computers, run models for the oceans and the atmosphere and the land surfaces. And once we're do a pretty good job in recreating that, we then say, let's look, it's our crystal ball into the future, and we turn the knobs. Let's add more greenhouse gases. Let's add more dust to the atmosphere, more smoke to the atmosphere, so on and so forth. And then see what that projects for the future. And I'll show you that just briefly. And then finally, the third thing is observations from satellites over the last 4 to 5 decades. Here from weather records going back to 1895, we can see for New Jersey every year since that time, this is the long-term average for that 127-year period. This is the trend over the last 40 years since we were able to really define a human influence emerging from the noisiness of the natural climate system. And we still have noisiness, which is part of the natural climate system, but it's on a trajectory that's influenced by human activities. And especially in the case of moisture, this is rainfall and snow, melted snow in Jersey. It's increasing, but notice the variability is increasing, feast or famine when it comes to wet years and dry years. This is 2011, the wettest year on record in New Jersey until 2018 came along. 2018 didn't have a big tropical storm like Irene to help jack up the totals, but it's rained often enough and heavy enough, it broke the 2011 record. So we're getting warmer in New Jersey at a disturbingly pace. We're getting wetter at a pace which is commensurate with the warming. Remember, a warmer atmosphere holds more moisture. For about a degree Celsius of warming, you can get about a 7% more moisture in the atmosphere. And interestingly enough, we've warmed a little more than a degree Celsius, and we've gotten about 7% wetter. So that's the take home. We're getting more variable conditions, wetter conditions, and warmer conditions, and more extremes. I've already alluded to what was going on in the Raritan Basin. These are photos, 4 photos I shot from major floods in Manville. I didn't get a shot in 2014. And now I live on the other side of the river, so I couldn't get over there to take a shot in Ida because every road over there was flooded. But you see 6 floods here with 100 years of the gauging station at Blackwell's Mills. 6 of the 8 largest floods have all been since 1999, going back a century. The first 80 years of that record had 2 of the top 8. We've had 6 of the top 8 in the last 20 years. So are we seeing more extremes? It's difficult, folks. It's difficult because extremes by their definition don't happen often. So you have to be a little bit patient as a climatologist. But when you start seeing this kind of repetitive nature to these extreme events, you gotta believe something is going on. Now, let me quickly turn to HPATCon and ice fishing. I got into this through a call from Washington Post a couple of years ago. So we're doing this new series on climate change. It's going to look globally, but our first of 6 or 8 installments is going to look at the Northeast, because we know it's warming pretty rapidly in New Jersey and up in southern New England. So we're going to look at Rhode Island, but we also got intrigued with looking at Lake HPATCon. I think they had heard about the harmful algal blooms, but they started saying, can you tell us something about ice boating, ice fishing? So I worked with these guys for a couple of months. And what I did, I plotted up winter warming. This is January, February, December, January, February temperatures, going back to 1895. This goes to 2018, or what is it, 27? Yeah, 2018, excuse me, 2018. I tried to update it, but the site I used from the National Center has been broken and I couldn't update it. But generally you can see a winter warming through that period of time, both in Sussex County and in Morris County. But notice in particular, not just the warming, but notice in Morris, average temperatures a century ago were in the 26, 27 degree range on average. And in recent decades, they've been closer to 30 or 31. And that's obviously incredibly important. The most important temperature on the Fahrenheit or Celsius scale is the freezing point of water. Yeah, boiling point's important. I'll agree with you on that, but it's the freezing point. It makes all the difference, whether it's snowing or raining, whether there's ice on the lake or the lake is ice free or the lake is whatever. So seeing this warming, we got some records, thanks to you folks, and with attempts for ice fishing, and going back just 2 decades. But the areas, the events in yellow there were canceled, or excuse me, run. They were run. The others were canceled. So out of these attempts, 27 were canceled, 19 weren't canceled. But these show you the average temperatures during that period of time in Morris County on this one for January, February, such. And you can see that mostly 26, you see a lot of 27s, I'm sorry, 21 here, 23. But when they were canceled, you see 33, 31, 35. So the take home here, I hate showing tables when I talk, but the take home here is that when the average temperatures in the winter are freezing point, you're just not being able to form enough ice to take on a fishing contest. You need to have those temperatures about 5, 6, average 5, 6, 7 degrees below the mark in order to get enough ice. Now we could look more carefully at this, and in one case I might add, there wasn't fishing held, not because of the lack of, in 15, there was so much snow on the ice that some of you folks no doubt know better than me, the weight of the snow can push down on the ice and screw things up. So it had to be canceled then, because not because the ice was necessarily thin, but the weight of the snow interfered with the ice, the consistency or the coherence of the ice. So there we are. You know, they used to harvest ice from Hepatcon and ship it off into the cities and all during the subsequent summer for the ice boxes a century and a half ago. It's just not there today because we're in an area of the world where we're getting near that freezing mark, and it's making all the difference. And as a matter of fact, that series was called 2 degrees C Beyond the Limit. This was, and you can see the byline for the very first article in that series was Lake Hepatcon, New Jersey. And what it's just, and because of that, it made the news. I went up and filmed something for the Today Show, sitting on a picnic table by the lake back there, I guess, in the summer of 2019. They talked to me for a half an hour and I had one sentence in the news report, which is typical. But this series of articles won the Pulitzer Prize in 2020 for reporting for groundbreaking climate change. I'm incredibly proud to have been part of contributing to that series by some fabulous science reporters, and to be in a small part of that. And Lake Hepatcon should be proud of being part of that series that was exemplary in the quality of the reporting. So let me just skip over that. We'll finish up here. What does the future hold? Here's where we're looking. New Jersey, North Jersey, the Mid-Atlantic, take your region. Temperatures are going to keep rising. The models show us that. The models show us steady or increasing precipitation, perhaps because we're getting warmer, the ocean's getting warmer, to bring us equal or more rain. With more energy in the atmosphere, we're going to see more variability. The extremes we're already seeing are likely to become more prevalent in the future. Storms, flood, when you don't have a trigger to wring that moisture out of the air, you got hot air, clear skies, and dry things out, and all of a sudden get too dry until the next trigger comes along to bring you more moisture. Then don't worry, up in Morrison, Sussex County, you're not going to have beachfront property anytime soon, I might add, but we're talking foot of sea level rise by the middle of the century along the Jersey coast. Perhaps 3 feet is the 50-50 chance by the end of this century. 5% chance of a 6-foot rise in sea level by the end of this century along the coast. with the temperatures warmer, it depends on you and I. We get a wide range in the models because we have to give them different emission scenarios. How quickly are we going to clean up our greenhouse gases and go and use less energy or greener, cleaner energy? So you can see there's a wide range, but still warming with low emissions. And if we're higher in the higher emission range, even a greater chance of warming, upwards of 10 degrees Celsius, Fahrenheit, excuse me, versus 5 or so. So it makes a big difference what we do now in terms of what our grandkids and great grandkids are going to see by the end of this century. And all the models show we are kind of locked in to 2050, somewhere in this range, but it's going to make a big difference as we get to the latter part of the century, what we do in the coming years and decades. With that, more extreme events, there's the wash from a local road. Excuse me. We have warmer oceans, more intense hurricanes, more energy. I've already mentioned that. And this gets back to increased rainfall. There was 2 studies recently done that I was in part involved with, but the reports came out of the Northeast Regional Climate Center. One added our return intervals for heavy precip now are based on the 1950 to 2000 period. Well, we updated that from 1950 to 2020. So we added the last 20 years to that. And we found that the recurrence intervals were about 5% changed. So the 50-year recurrence interval has about 5% more precipitation than it did when we just looked at 1950 to 2000 instead of 1950 to 2020. So that showed us that we're getting more of our rain in heavy events. But the second study was running models into the future, and they all show a greater chance of more precipitation in extreme events. Now you can look at it 2 ways. The 50-year event becomes larger, or what today is a 50-year event becomes a 30-year event. And the models showed that by the end of this century, a 100-year event today is a 50-year event. It happens twice as often as today. Doesn't mean it happens all the time. It's not like it's 1,000 times more. But we're going to see more of these extreme events because we're continuing to warm our climate system, our atmospheres, and our oceans. Impacts, I knew I wouldn't have much time to get into this tonight, but I didn't want to ignore it. We're seeing these impacts already. They're going to be exacerbated in the future. Human health, our agricultural, our natural systems, our coastal environment are all currently being impacted by our changing climate, and it's only going to be worse or more exacerbated in the future. Finally, just to introduce you at the very tail end here to the way we're keeping an eye on what's going on. I mentioned this weather network we have. This is a network of 67 automated stations situated around New Jersey. In fact, this is even a little off because we just added a station in Little Falls on the campus of Montclair State. And we also recently added a station up in North Halden near cooperation with William Patterson University. But you can see up in your neck of the woods, we have Pequest, Hackettstown, Parsippany. This is Charlotteburg up at the reservoir. This is up in Vernon at the top of the ski lift. And then we've got several stations, and they're all even shown here. High Point Monument, 200 feet below that, and in Wantage, a couple 100 feet below that. That's School of Conservation in Stokes Forest and Sandyston. And that is generally the coldest cold air drainage station in the state, Walpack. But you notice there's a bit of a hole here. So if anyone happens to know of a good location and has some knows of a resource to get money to put in one of these automated stations, give me a yell. I said that last we're going to get a station in Union County in the coming months. This is what the Charlotteburg Station looks like. All these variables are measured every 5 minutes. Now, most stations, we don't measure snow acoustically. We have one out at Sandyston, but soil moisture adds solar radiation and climate variable. And to them via modem every 5 minutes. So there's our 24/7. It was immeasurably helpful during Sandy, during Ida, and many other events. But we also have a volunteer group of observers called COCORAS, Community Collaborative Rain and Hail Snow Network. It's a national network. We in the State Climate Office manage it for New Jersey. We have about 300 active observers in the state who once a day go out and precipitation in a standard gauge about $35, mounted in an open area, so it's not under a tree or the eave of a house. There's snow, and takes the most training, but there's online training, videos, written materials, and then you go online and enter your data. And you're not obligated to do it every day. We have about 300 active observers. About 125 of them missed a week or fewer observations in 2021. But it's a great thing for people of all ages. It's citizen science at its best. So if you're interested, just Google cocoras.org. Just yesterday, I got word we have 2 new observers signed up in the state. So it's a wonderful, interesting program. And we even measure snow depth and the water equivalent of the snow, which is very helpful for flood potential from rapidly melting snow. So let's sum up here. I'm starting to drone on. We have a wide variety of weather in New Jersey. A lot comes in the nature of extremes. And the climate is changing. And with that, we're likely to accelerate the warming, accelerate the moisture, expect more extremes. And with that, more impact. Now, we didn't get in with this. There's mitigative activity, reduce our greenhouse gases. We're going to have to learn to adapt to do those storm drains and change our regulations and such. So, and communicate better so we can get out of harm's way, because we're not going to be able to engineer ourselves totally out of this. We can't afford that. We can't build pipes that are big enough. So we need to communicate better. Finally, we need to keep an eye on things because it helps us in the short term for the extremes and monitoring the long term. But I want to leave you with a little bit of hope, and we maybe some questions about this. Time remains. We can still moderate things a little bit. We're not going to get ourselves out of the woods fully, but we can slow the train, if you will, that has left the station through mitigative activities. And then we also need to be better prepared through adaptive resources. And with that, I just want to, you can look at this online, but there are some good resources. This is a wonderful 50, 60-page primer put out by the National Science and the Royal Society. You can get this for free, download it online as a PDF. This comes out of the state summaries produced by the National Centers for Environmental Information. It's just updated. I guess I was involved with some of this. This is 2 state reports, State of the Climate and What to Do About It, that came out in the last 2 years, 2020 and 2021, from New Jersey Department of Environmental Protection. And then finally, Rutgers, we have a Climate Resource Center and a New Jersey Climate Change Alliance, packed full of interesting information and tools that are being developed to deal with flooding along the coast, some inland flooding, and heat, and on we go. So with that, it doesn't look bad at PACCON all the time with floodwaters. There's my email address. I'd be happy to answer any questions you have. If you want a copy of the slides, let I know we're at an hour here. Some of you have to go, but I'd be happy to entertain any questions you might have. Thanks very much.
Thank you,
Oh, I'll
Dave.
jump in here with you, Dave, real quick. I'm sorry, Donna.
Okay.
I'll just read through some of the chat. So Fred Ludnow, who works with Lake Hopatcong as the Director of Aquatic Programs at Princeton Hydro, said that yes, in general, the mid-Atlantic region of the US is getting warmer and wetter, which is interesting since many regions of the US and the world will be seeing less precipitation. And he says, we have seen a statistically significant increase in the galactic surface water temperatures at the Mid-Lake Station at Lake Hopatcong over the past 30 years. Have you seen similar increases in surface water temperatures in other lakes and reservoirs in New Jersey?
Yeah, thanks for that question. And yeah, the warming is ubiquitous globally. The wetting isn't necessary. Southwestern US, the dry is going to get drier, and we're already seeing that. But here, first of all, we don't have good long-term records of water temperature. You have a 30-year record. I'd love to see a link to that record. We do have sea surface temperatures off the Atlantic coast gathered that have shown this warming. And that's part and parcel why the mid-Atlantic is warming and the Northeast is warming faster than other parts of the country. Some of it's associated with the fact that the offshore waters are warming so much. But, you know, I don't have the data. I couldn't get online to get a time series of summer warming because the HABs I know are so important. But our summers are warming, to me, more seriously than the winters. Yes, the winters are warming and we're flirting with that freezing line, but the summers, and it's not just record highs, it's the persistence of the warming. It's coming earlier, staying later. We're not getting as many breaks during the middle of the summer. And it's not just the daytime highs, it's the nighttime lows are staying higher. And that's clearly leading to the warming of lake waters. And then you throw in more precipitation and the septic fields there and so on and so forth. And you've got, like I'm telling you folks, a recipe for some real problems. And I don't have a lot of positive things to report in terms of the increase in warming and probably the increased precip. There, I think we're going to have to deal with this through mitigative activities that can be applied, but you folks can speak in many respects better than I to that. So thanks for that question.
Thank you. So Cliff London also commented back when we were discussing the ice on Lake Hopatcong that over his 70 years at the lake, less ice, it forms later and leaves earlier. So Larry Orleans asks, if the US is able to reduce our emissions, but China and India and other countries do not, how will it affect our local climate, if at all?
Yeah, you know, that's an extremely challenging question. And one open for grand debate. And there's environmental justice questions or issues associated with that and so on and so forth. First off, one way of looking at it, and not to throw the guilt on, but when you look at the net emissions that have been emitted to this point historically, the US dwarfs others. China has caught up and passed us. Perhaps India will at some point. But, you know, you hear mixed messages of looking to plant 1 billion trees in China, but they're still opening coal fired power plants. You have environmental justice issues in terms of telling people who are just starting to climb out of the depths of poverty that, no, you can't use energy, but maybe we can get clean energy to people. So it's an incredibly complex question. But, and let me finish by saying, as I've alluded to already, everything's connected to everything else. So what we do here isn't just impacted on New Jersey or the United States. It has a global effect. But likewise, so does everything happening on the other side of the Pacific and, halfway around the world has impacts on what happens here. So it's truly a global issue, a global struggle. One is fraught with politics and justice issues and so on and so forth. But I mean, if we can't set an example here, how are we going to climb out of it anywhere? I guess that's another way of looking at it. So I'll stop preaching. Head on to the next question.
Well, quick comments. Cliff London says, great job on the presentation. He just wishes more people were here to listen and learn. And Rob Baum says, thank you for the presentation. He says, while a multifaceted problem and immediate action we can all take tomorrow is eat less meat, animal agriculture is a major contributor to greenhouse gases and draws heavily on water resources relative to other forms of agriculture. He says, PSAO.
It does. Now, New Jersey doesn't have even much of a cow population any longer, but other parts of the country, and I'm not going to preach vegan and whatever. People have to make choices. People have to look at their lifestyle and make decisions on how they might wish to help solve the problem. But yeah, we know that it contributes, eating meat contributes quite a bit. Yeah, it's a very complex problem. Now, you mentioned more people hearing about this, due to the Murphy administration and the First Lady's involvement. There is climate change is being taught throughout the schools in New Jersey in all disciplines. I've briefed the Department of Education, and when I gave my briefing, it wasn't just science curricula that were being looked at. It was humanities, it was even health issues. And they're trying to tie that in to the whole genre of climate and climate change within New Jersey's curriculum. So our kids will hopefully get a better appreciation of what's going on. And maybe they're the ones that are going to guide us in the future. I like to kiddingly say my generation got our parents to put on seatbelts. Maybe my kids' generation, they're in their 30s, helped with recycling, brought that home. Maybe our kids are going to bring home more awareness of using our energy more effectively, efficiently, so on and so forth, and bring awareness of climate change. I don't know, maybe that's a wish, but we've seen how our young generations are so wonderful in those regards.
True. Do you want to circle back around to the question about giving rising rain numbers? Should towns be paying attention to redesigning storm basins for big developments?
Yeah, I'll go back to that. I kind of addressed that some with the latest reports, and there are rumors and it's been in the media that there's going to be some potential changes to, DEP is not just, an environmental monitoring agency. There, as you well know in the background, they're a regulatory agency as well. And they may be putting out more regulations on how we have to, where we can build, raising expected flood heights, and not just along the coast as has been done, but inland. So stay tuned for some of those changes, regulations. But I know the engineers are very interested in this. Developers are interested. The environmental lawyers on both sides are certainly interested in this. So it's going to be, I say interest again, it's going to be an interesting discussion, shall we say, out there. But again, I also said, and I mean it seriously, we can design bigger retention basins and larger culverts, and where that road washed out. If we had a bigger tunnel underneath that culvert, underneath that bridge, it might eliminate a washout. But there comes a point where extremes get so large that you can't build for them. You just can't. And you're going to have situations where the key is we may lose infrastructure, but how can we avoid losing lives? And that's where we get into the communication side of things. So there's things we can do, and regulations are no doubt going to change, just like a horticulturist or someone growing peaches and apples in New Jersey is going to look to different cultivars when they plant new plants, because the cultivars here now need a certain number of hardening hours during the winter of cold temperatures. And they're going to say, we're not getting those anymore. So we're going to plant cultivars that are more commonly found perhaps in Virginia and do them up here. So they're going to have to adjust and are adjusting as well. So the key here is understanding. I didn't get into that preachy side of things, but we need to understand things. This isn't about believing the climate is changing or anything like that. It's understanding. And that's why I'm glad it's in the schools. That's why thank you for tuning in tonight. The better we understand what's going on out here and what's likely to happen, the more unified we can be and the more attention we can pay to dealing with it and dealing with the social injustices, the environmental injustices, and the safety aspects to everyone. I see people starting to leave, so I better be quiet.
Well, everything else is really just a lot of thank yous and really nice presentations. So.
Great, great. It's been a pleasure, and I hope you have a great summer up there. It's going to be warm, but so far the pattern hasn't locked into exceeding warmth, but our summers are getting warmer. Precip, anyone's call. They expect an active tropical season in the Atlantic. That increases the chances something could get up here, but it doesn't guarantee that an ECASIS and a Floyd and an Ida are going to get up here. But be on guard. That's all I can say. Be on guard. But have a great summer on the lake.
Well, thank you so much, Dave. We really appreciate you taking the time, and thank you to all our folks that are online to listen to us this evening. We'd like to also extend our thanks again to the New Jersey Council of Humanities for providing the funding for this program. And we'd like to remind folks that this is part of our Lake Apacon Historic Flood. We also do have a photo exhibit that is available on our website through June. It's a lot of fun to look at the pictures there. So thank you again, everyone, and have a wonderful evening.
Thank you all. Good evening.